Well, hello there, everyone. This is Richard, and I want to welcome you back to Stuff We Can Do in Excel. It's a beautiful morning here in Tennessee, so I hope you all are having a great day also. What we're going to do in this video is we are going to look at how to add trend lines to our pivot charts. Here's the data we've been working with. I've already got it in a table, and if you recall, to create a pivot chart, I'm going to click anywhere in the table. I'm going to go up to Insert, and over in the center under Charts, I'm going to go do the drop down for Pivot Chart, and I'm going to choose Pivot Chart and Pivot Table. Many videos would tell you just to go ahead and do over here to add a pivot table, add a chart later. I like to go ahead and just do them both at the same time. So I'm going to add the pivot chart and the pivot table. And it's going to be there. I'm going to put it on a new worksheet, so I'll say okay. And so now what I'm going to do, I'm going to put, I'm going to not format the chart area right now. I'm going to go put the sales down here and the cost of goods sold, and I'm going to put year in here. Now, one of the things I'm also going to do with this data is I'm going to actually go ahead and change the colors, just because I like changing the colors. I'm going to make that more of a light green color. There's a reason I like that color, and we're going to use that color, and then I'll get into the dark orange for the other. So I would add, I might want to add labels to this. So there's my data label. So the green is my sales, the orange is my cost of goods sold. So I've got that information there, and I'm going to actually go use this one. So I've got all that information. If I add my data labels, there we go. So I've got all my information there. The question then is, what if I wanted to add a trend line to this data? I wanted to see what the line looks like. Not only want to see what it looks like, I'd like to see the model for it. So it's pretty simple. If I just click on any one of these section of bars. So if I click on one of the green ones, it's going to highlight all the green ones. If I click on one of the orange ones, it'll highlight all the orange ones. So if I click on the green bar, and then I right click with my mouse key and go down to Add Trend Line, it's going to add a line to this data. Now you can see this line. It defaults to a linear line, a linear model. Now that actually doesn't look much like our data. And in fact, if I go down and look at display the equation and display the R square, we're going to see something very interesting. Now, if you don't know how to do this and aren't familiar with this particular tool, I've got another video in the resources area on creating linear models using Excel, so you can go watch that video. But if you already know how to do that, this is kind of familiar to you. So what I'm going to do is I'm going to make this bigger so we can see it. And you can see that my model for this line, y equals mx plus b, right? So here's my y. My slope is 457.14 times whatever my x is, and my intercept is 65,552. The problem with this line is it's not a very good line. I can tell that because my r square is only 0.0138. Remember, we want this r square to be as close to 1 as possible. It tells me, so if you look at each one of these points, you'll see that every one of these points is either above or below the line. And so what we do is we take the differences and we square the differences, and we try to find the line that has the smallest sum of squared differences that we can find. The reason we squared them is these up here would be positive differences, these are negative differences, and if you square them, they're positive. And then we add all those up, and we try to find the line through this data that has the lowest sum of squares of differences. And this is the line that gives us that. I don't particularly like the line. It's not good. We can change this line, however, if you go into our tools, and I'm going to go up. I'm going to click on the line, and when I click on the line itself, it's going to bring me up. I can go in and I can format the trend line, and it's going to give me some options over here on the far right. It defaults, as like I said, to a linear line, but I might want to try a different line, a logarithmic line. Now watch this model up here. If I go with a logarithmic line, I can get to 0.1034. That's still not very good. If I go to a polynomial line, and this data does sort of look like it goes up, it goes down, it goes up again, sort of looks like this polynomial here. Click on that. With the order of 2, I'm going to get a model of 0.4351. That's still not very good, but it's much better than 0.015, right? So if I go to order of 3 factors, I can get that to 0.8279. And watch this, if I go to 4, it jumps to 0.9621. That's a pretty complicated model, but at the same time, it's a much better fit for this data than the original model was. I can go to an order of 5 if I want to on this, and it really doesn't give me much more. So I'm going to stop with an order of 4. I generally use the rule that simpler is better. Unless I'm getting a really big change in improvement, I don't go that next level. So let's look at what happens if we model our cost of goods sold data. So I'm going to click on that, then right click and add a trend line to my cost of goods sold data, and that looks like a straight line. And what's interesting about this one, if I do my equation in my R square, and it's up here, but I'm going to move it so we can see it better. And in fact, I'm going to move this whole thing over so we can fit it in here a little better. So if I take this and bold it, and I'm going to actually change the color, I'm going to make that bigger so we can see it. I want you to look. This model, this straight line, already has a 0.9466 fit to it. Okay, that's pretty doggone good fit. And just with a straight line model. And the data sort of looks a little straight line, but watch what happens when I go in and I format this trend line. If I go to a polynomial for this data, it jumps to 0.972 immediately. I can increase it, and I get to 0.9726. I go to 4, I get to 0.9994. Boy, that's pretty good. So I get, at the same level of order if I have of the other one, I get a 0.9994 fit for this data. That's a pretty doggone good model. And both these models together would allow me to sort of predict what my data for the next period might be. Now I'm going to do another video where we look at forecasting and see what that might work for us, how that might work. So hopefully this shows you how to fit a trend line to a pivot chart that you create from your underlying data.